Picture an ocean teeming with life, colorful coral reefs, swirling schools of fish, and a delicate balance that supports countless species. Now, imagine that same vibrant world transformed into a barren underwater desert where almost nothing can survive and the silence is deafening. These are marine dead zones, vast stretches of ocean so depleted of oxygen that most marine life either flees or perishes, leaving behind a ghostly emptiness. This dangerous condition, known as hypoxia, is often triggered by a process called eutrophication. It happens when excess nutrients, mainly nitrogen and phosphorus from fertilizers, sewage, and industrial waste, flood into our waterways, usually as a result of human activity. As oxygen levels plummet, mobile creatures like fish and crabs desperately swim away in search of safer waters, but slower or immobile animals, such as clams, oysters, and marine worms, are left behind, unable to escape, and often suffocate in place. Dead zones can be temporary, appearing seasonally, or they can persist for years, causing long-term damage to local ecosystems and the communities that depend on them. Today, scientists have identified hundreds of dead zones around the globe, from the Baltic Sea in Europe to the Chesapeake Bay in the United States, threatening some of the world's most important fishing grounds and coastal economies. The root cause? Our actions on land. Agricultural runoff, overflowing sewage, and urban stormwater all carry nutrients into rivers and eventually the ocean, overwhelming its natural ability to process them and throwing delicate marine systems out of balance. When oxygen is depleted, the normal cycles of marine life collapse. Coral reefs bleach, fish die off, and once thriving habitats become underwater wastelands, unable to support life as they once did. By understanding how dead zones form and what causes them, we can take meaningful steps to reverse the damage, restore ocean health, and protect these vital ecosystems for future generations. Each summer, a massive dead zone forms in the Gulf of Mexico, a phenomenon that has become one of the most dramatic examples of human impact on the ocean. This area, where oxygen levels drop so low that most marine life cannot survive, emerges like clockwork as the weather warms. The dead zone stretches for hundreds of miles along the coasts of Louisiana and Texas, impacting both the environment and the communities that depend on these waters. This hypoxic area can cover up to 22,000 square kilometers, sometimes as large as the entire state of New Jersey. In some years, it even surpasses that size, making it one of the largest recurring dead zones in the world. The main culprit? The mighty Mississippi River, which acts as a giant funnel, channeling nutrient-rich runoff from nearly 40% of the United States. After spring planting, the river swells with water carrying fertilizers and other chemicals from thousands of farms and cities upstream. Fertilizers, pesticides, and other pollutants wash off farmlands and urban areas, flow into the river, and eventually pour into the Gulf. This triggers explosive algal blooms, which consume oxygen as they die and decompose, leaving the water starved of life-sustaining air. The Gulf's warm, layered waters act like a lid, preventing oxygen from mixing down to deeper layers. When bacteria break down the dead algae, they use up what little oxygen remains, suffocating the bottom waters. Fish and shrimp can escape to safer areas, but bottom dwellers like crabs and worms often perish in place, disrupting the entire food web and causing ripple effects that can last for months or even years. This crisis threatens the region's billion-dollar fisheries, putting the livelihoods of shrimpers, fishermen, and seafood businesses at risk every year. The dead zone lingers until autumn storms finally arrive, churning and mixing the ocean waters, restoring oxygen, and allowing marine life to slowly return. This annual event is a stark reminder of how pollution from land can devastate entire marine ecosystems, showing just how connected our actions are to the health of the ocean. Reducing nutrient runoff upstream, through better farming practices, wetland restoration, and conservation efforts, is crucial to shrinking the Gulf's dead zone and protecting both marine life and coastal communities for generations to come. The main driver of dead zones is nutrient pollution, primarily nitrogen and phosphorus, from human activities. Industrial agriculture is the biggest source. Fertilizers not absorbed by crops are washed into rivers and eventually the sea. Urban runoff, lawn fertilizers, pet waste, and inadequately treated sewage add to the problem. Industrial facilities also discharge nutrient-rich waste, compounding the crisis. A single molecule of fertilizer can travel from a Midwest farm, down the Mississippi, and into the Gulf, fueling dead zones. This pattern repeats worldwide wherever intensive farming and dense populations are near coasts. Our land management choices have global consequences for ocean health. Identifying these sources is the first step to stopping nutrient pollution at its origin. Eutrophication starts when excess nutrients flood coastal waters, triggering explosive algal blooms. These blooms can turn the water murky and block sunlight, killing seagrass and other plants below. As algae and shaded plants die, they sink to the seafloor, creating a feast for bacteria. Bacterial decomposition consumes huge amounts of oxygen, especially in stratified waters where mixing is limited. Oxygen levels plummet, suffocating marine life. Fish escape if they can, but bottom dwellers perish. The once thriving ecosystem collapses into a dead zone. Recovery is slow, often requiring storms to re-oxygenate the water. This entire chain reaction is set off by nutrient pollution. Preventing algal blooms is key to protecting marine life from hypoxia. In a healthy marine ecosystem, nutrients are balanced, creating the foundation for a thriving underwater world. Every organism, from the tiniest plankton to the largest predator, plays a role in maintaining this delicate equilibrium. Algae are kept in check by grazers, and oxygen flows freely through the water, supporting a wide variety of marine life. Seagrass meadows and diverse plant life provide essential habitat, stabilize the seabed against erosion, and help filter the water, keeping it clean and clear. These lush underwater forests support a rich food web, offering shelter and food for countless species. Natural checks and balances, like predators controlling prey populations, maintain resilience and biodiversity, allowing the system to recover from small disturbances, such as storms or seasonal changes, without losing its vitality. In contrast, an unhealthy, eutrophic ecosystem is dominated by algal blooms and loses its diversity. Sunlight-blocking algae kill seagrass, destroying habitats and reducing resilience. The once vibrant seabed becomes barren, unable to support the life it once did. The food web collapses from the bottom up, as primary producers and small creatures disappear. The entire ecosystem becomes vulnerable to further stress, unable to bounce back from new challenges. While some low-oxygen zones occur naturally in the ocean, supporting unique forms of life, today's dead zones are larger, more frequent, and spreading to new areas, driven by human activity such as fertilizer runoff and pollution from cities and farms. Marine life can't adapt quickly enough to these rapid changes, leading to mass die-offs and long-term damage. Restoring balance means tackling nutrient pollution at its source, protecting wetlands, and making sustainable choices to give our oceans a chance to recover. Dead zones devastate both marine ecosystems and coastal economies. The loss of bottom-dwelling organisms disrupts the food web, forcing fish and shrimp to migrate or die. Fisheries suffer. The Gulf of Mexico's dead zone costs the U.S. seafood and tourism industries millions each year. Fishermen travel farther for smaller catches, increasing costs and hardship. Algal blooms can also produce toxins, close beaches, and drive away tourists, hurting local businesses. The ripple effects are felt throughout coastal communities, from restaurants to hotels. A degraded ocean can't support robust economic activity or withstand other threats like climate change. The Gulf's dead zone is a warning. Our land-based actions have direct, costly impacts on the sea. Protecting oceans from nutrient pollution is essential for both environmental and economic sustainability. The good news? Dead zones can be reversed with decisive action. Short-term solutions include stricter regulations on industrial discharges and upgrading wastewater treatment to remove nutrients. On farms, buffer zones of plants along waterways and precise fertilizer use can dramatically cut runoff. Long-term, we need to shift towards sustainable agriculture. Healthier soils, cover crops, and diverse rotations reduce the need for synthetic fertilizers. Everyone has a role. Farmers, industries, policymakers, and individuals must work together. Investing in green infrastructure and sustainable practices shrinks dead zones and restores marine life. When nutrient pollution drops, dead zones shrink. Science proves it. By acting now, we can revive our oceans and secure a healthy future for coastal communities and the planet.